Right, so welcome back to your favorite inorganic tutor YouTube channel. Today we are going to look at how we can solve some particular problems of the inverse trig functions. Right, I will take you through about let me say 5 series of questions as to how we can solve the inverse trig functions when you are given a problem. We have already known how to find or how to prove the inverse trig function. So now let's go. Now our first problem is going to be sine inverse of s squared plus 1, right? And we know that the formula for sine inverse is equal to 1 over square root of 1 minus u squared du dx, right? So what we do right here is that we have to identify our u and then we identify our du dx, right? So we all know that sine inverse of u right here is this. So the u right here is the whole of this function, right? So we have u equals x squared plus 1 right here. So we have to find du dx. So du dx is equal to 2x right here. So now we have our du dx. What we have to do is to find the 1 minus u squared, right? So we know that 1 minus u squared is equal to 1 minus the whole of u squared. 1 plus s squared, right? So now we have 1 minus u squared as this, and we have du dx as 2x. So we can say that dy dx is equal to 1 over square root of 1 minus 1 plus s squared all squared, then 2x, right? So we can rewrite this as 2x all over square root of 1 minus 1 plus s squared all squared. So this right here is our solution to this particular problem. Let's look at how we can tackle another one as well. So question 2, tan inverse of s squared over s plus 5, right? So right here, what we have to do is to identify our u, and then we know the formula for the tan inverse, right? So tan inverse of u is equal to 1 over 1 plus u squared du dx, right? So what we need right here is to identify our u, and we know that the u is the whole of the function inside the tan inverse, right? So we say that u is equal to s squared over s plus 5, right? So we have to differentiate this. So when you differentiate this, you're going to have du over the x is equal to differential of this. You're going to use the quotient rule, right? We know that any function, two functions dividing each other, you have to use the quotient rule. So differentiate this, you have 2x, then you maintain the denominator, which s plus 5, minus maintain s squared, then you differentiate the denominator, which is 1, all over s plus 5 all squared, right? So we have du dx equals, when we expand this, we are going to have 2s squared plus 10x minus s squared all over s plus 5 all squared, right? So we have to simplify this, and we are going to have s squared minus 10x plus, rather, all over s plus 5 all squared, right? So we have our du dx right here. So we have to look for our 1 plus u squared, right? So 1 plus u squared right here is going to be 1 plus x power 2 all over s plus 5 all squared, right? So we have to expand this and simplify, right? So we have 1 plus u squared is equal to 1. Of course, this over 1 plus this one, you expand it, you're going to have s power 4 over this squared, right? So when you find the LCM for this, right, we have this. So this goes here, and we have s plus 5 all squared plus s over 4 right? So this is the 1 plus u squared right here. So we have to take, the formula says that 1 over 1 plus u squared du dx. So we have to take 1 over 1 plus u squared, and that is equal to 1 over s power 4 plus s plus 5 squared all over s plus 5 squared, right? So we know that this 1 is of course over 1. So we have right here, this turning upside down, so you have s plus 5 all squared all over s power 4 plus s plus 5 squared, right? So this is our 1 over 1 plus u squared. So we have to multiply it by the du dx, and then we are going to have dy dx as this s plus 5 all squared over s power 4 plus s plus 5 all squared times the du dx, which is right here, s squared plus 10x all over s plus 5 all squared, right? So we see that this can clearly take off this, and then we can say that we have the y over the x is equal to s squared, or s squared plus 10x all over s power 4 plus x plus 5 all squared, right? So this is our final answer to this particular problem. This particular problem right here. This particular problem. This is our final answer, right? So let's look at our next problem. Let's look at our next problem. So our next problem is going to be cot inverse of 4x, right? So 3y is equal to cot inverse of 4x, right? And we all know the formula for cot, right? So cot is cot of u, cot inverse of u is equal to negative 1 over 1 plus u squared du dx. Negative 1 over 1 plus u squared du dx. So that is the derivative of the cot inverse of u, right? So right here we can see that this is our u. So we can say that u is equal to 4x. So du dx is equal to 4, right? So we have to identify our 1 plus u squared. So 1 plus u squared is equal to 1 plus 4x all squared. And this is equal to 1 plus 16s squared, right? So this is our denominator right here, and this is our du dx. So we can say that d dx of cot inverse of 4x is equal to negative 1 over 1 plus 16x squared. Then our du dx is right here to be 4, right? So we say that this is equal to negative 4 all over 1 plus 16x squared. And this is the answer to this particular problem. So let's move on to our next problem, which is the tan inverse, right?